This is question 1 of 5th book Radioactivity Toy Time 1. So 1 begins, radon is a gas produced by some types of rocks. Radon is a natural source of radioactivity. What is the name for this radioactivity? So the answer here is background radiation. This is a good definition for background radiation, natural sources of radiation in the surroundings. In part B, there are 2 sources of alpha radiation in some houses: radon gas in the air, solid americium in smoke alarms. The alpha particles from radon are a greater risk to health than the alpha particles from americium. Explain why. So I think there's 3 relevant points here, of which you might put down 2. First one to do with the range of alpha particles. We know that the range of alpha particles in air is low. They can only travel a few centimeters. This is going to be relevant because of the location of the radioactive sources, which would be our second useful point to put down. Radon is a gas, so therefore it's all around us. Americium will only be inside the detector and therefore is never likely to be inside our body. When we put these first 2 together, that means that the alpha particles are never likely to make it to us. The third point that we might put in, which is similar to the second, is the idea that radon can be inhaled, whereas the americium is never going to be inhaled by a person. It's only ever going to stay outside their body, where it's much less dangerous. Part C, radon-222 and radon-220 are both isotopes of radon. A nucleus of radon-222 has 86 protons. How many protons are there in a nucleus of radon-222? So the answer is the same. The name of the element, in this case radon, defines by its number of protons. A nucleus of radon-222 has 136 neutrons. How many neutrons are there in a nucleus of radon-220? So the number written here next to the radon-220 is its mass number. We know this is the number of protons plus neutrons. As we've already said, the number of protons is unchanged. So if our mass number is 2 less, then our number of neutrons must be 2 fewer as well. Part D. The graph shows how the activity of a sample of radon-220 changes with time. Complete the graph by adding the missing unit for activity. So our unit for activity is the becquerel, which is abbreviated BQ. That's a capital B and a lowercase q. Complete the graph by adding the missing unit for activity. We've done. Explain what is meant by the time half-life. So it's the amount of time for 50% of the radioactive atoms to decay. And for the last part, use the graph to find a value for the half-life of radon-220. So as we did in the lesson a few times, we do this by drawing lines across and down. As ever with these graphs, once they've been printed into OneNote, the lines aren't all that helpful. So we want to be, if we're going from 700, so it seems sensible to say that it starts at 700 at the top. So we'll go down to the time it takes to get to 350. I'm going to put on a slightly narrower line to help. Cross them down as best we can. And here we want to check carefully on the scale here, but we can see there's 5 small squares going from 0 to 25. So each small square has a value of 5. So this line here appears to be just under 55 seconds, maybe 54 seconds. On this particular paper, they allowed 55 seconds plus or minus 1. So 55 seconds. I'm going to put down here, they've already put the unit in for me.